All right, so this is lesson 9. It's probably one of the more challenging ones. Here we have to just take real life things like sunrise or height of a Ferris wheel or depth of the ocean and changing tides. And those things will be modeled in real world things as trig functions. For the majority of this is actually just a, run this with your calculator sort of unit. So I can do some interpretation stuff as well, but all I'm going to do first is if the depth of water in the harbor is this, I'm just going to type it in, 12 plus 5 cosine of 0.5x, because I don't have a t value. Oh, my x didn't go in there. There we go. Close my bracket, and I'm good to go. Now if I go graph, I probably won't see it. In fact, I know I won't see it because my midline will be at 12, and it'll go up and down 5 from there, and I'm only going, my window is only to 4. So I'm going to always change my window to match the domain that I've been given here. So my domain is going to go from 0 to 24. I might as well go by 1s or 2s. Let's even go by 2 hours here. And then if I hit graph, one of the things that works really, really well for trig graphs, but not very many other graphs, is zoom fit. What zoom fit does is it finds the maximum and minimum value and then just plots those for your y values. The reason it works well for sine and cos is that they don't go radically beyond those values. Things like exponential curves and parabolas that have no maximum value are really going to make your life miserable if you try and use zoom fit. But zoom fit works lovely for trig graphs, assuming that I have the right domain well established. Maximum and minimum, I could just look at these things off the graph. I could go second calc. Max, left bound, so I just went a little bit to the left of there. And now it should tell me my max is 12.56. I've definitely done something wrong there because the max should be 17. Oh, no, there it is. Good thing I'm paying attention. My max is 17. I was just looking at the wrong value. Anyway, my minimum value will be 12, which is just the 12, 7, which is just the 12 minus 5. Period of the function, I just have to look on here. And again, I can find from minimum to minimum, but I can also just use that my period equals 2 pi over my b value, which in this case is 2 pi over 0.5. Which would be 2 pi over b, 4 pi. Let me go. A little bit mixed up there where I was going with it. Anyway, suitable window is just going to be x between 0 and 24. And assuming I've got these values, I can even go a little bit outside of there. I can go from 6 yeah, there's my window settings. Depth of the water the nearest 10th at 2 a.m. So my t represents hours after midnight. So all I have to do is go back to my graph and put in x equals 2. So graph, second calc, value, x equals 2. So the depth of the water is 14.7. And then if I wanted to find at what point it's going to go under 8.5 meters, that's a y value or a depth value. I'm going to put in 8.5 here, and then I can see where the values are that it would ground, though the water isn't deep enough. So I go second calc intersect. And first curve, second curve, guess. So I'm going to guess like, I don't know. Can't even come up with a good guess. There we go. 3.8. All right, so I was paused there for a little bit, and I did some stuff without thinking that you needed to see what I was doing. But anyway, I looked on my graph. I found my minimum, which was at 4.69. I'm now going to find the other intersection, this one right here, and do that. I go second calc, intersect. Again, first curve, second curve, guess. So I'm just going to move towards there. I just have to be close to it. I don't have to be on it. And there's my other value, 7.87. Now, this is the thing that's a hassle, is that these are both the hour values, but they don't want hours, they want hours and minutes. So what I have to do here is take that value, 7.87, take the 7 part off. So I just get to the fraction part. That I multiply by 60. So that's going to be 7:52 a.m. And this is going to be 4 and then 69 60ths, so 0.69 times 60. That's 41.4, so it's going to be 4:41 a.m. So it has to get out of the harbor before 4:41, and it can come back by 7:52. Basically, same idea here, right? You just plot the thing in, and then go with it. So back to said calculator, back to my y equals, clear. Now just be careful with your brackets, right? This is where you need to make sure that what you've told the calculator is what you actually intended to tell the calculator. I like putting brackets around my b value, whatever that is. Times x minus 78, close bracket, divided by 365, close bracket, open bracket, close bracket. Okay, that's good. Open, closed 1. So I've got 1 open, 2 open, close, good, plus 6.3. Now, if I've done this right, I should see my graph. I'm going to need to change, though, my window setting to, because it's days of the year, my x values are going to go from 0 to 365. My y values, if just looking at this, have to be around 6.3. So I'm going to say like 10 and 3. And my x scale, I'm going to say like 30, and then it's about a month, right? That kind of gives me a approximate month-by-month piece. That looks pretty good. Again, a suitable window, basically the graph should just take up a little bit more than half of the thing. So I've done that pretty well. So what my window was, where I came up with it again. Okay, sorry about that. My phone rang and then class changed and whatever. But this is my new window. And now that we've got the window set for my domain really well, I'm going to do zoom fit. And what zoom fit's going to do is it's going to let me adjust my y value settings. Yeah, it works pretty well. So my x values are from 0 to 365. So we've now got this thing in here, and now I've just used this to figure out what I'm doing. So my y values, just looking at my window, are like 4 to 8. And again, anything in that would be fine. You could go a little bit lower than that or a little bit higher than that. Just make sure you can see all the values. My calculator just does the rest of this for me. So figure out how early the sun rose on the 127th day of the year. Well, then I just go second calc value, and the value I put in is 127, and my oh, that's not quite right. Let's try that again. Forgot the 2. Or it didn't register my slowly but surely. So on day 127, it was 4.96. Now that's hours, not hours a minute. So I'd go 4, and then I'd take away the 0.96 and multiply it by 60. I'm too lazy to do that, so I'm just going to put it like this. Yeah, close enough for me. And then on which days the sun rose at 7 a.m., this is where I'm going to actually put that in as a y value here. So there's my 7 a.m., and we're going to graph that. And now to figure out which days that was, it's my intersect. And just have to make sure I'm moderately close to one of them. So first curve, second curve, guess. So this one's day 54. And again, it's probably a couple days on either side of that would actually happen. Not just that particular place. And then guess, I'm going to guess now somewhere like 200, just so I don't have to scroll over to it. And that should be somewhere, oh wow, I'm good. Well, not quite that good, 283. I missed it by a lot, but that's okay. I was close enough. So 283, 284, rounding lines. So that's the end of that one. Hopefully that makes sense. If not, come in, get help, all that other good stuff that I always end with. So, the end. Randy.